25 meter steel wire, 25 meter steel wire and 50 meter copper wire are attached end to end and stretched to a tension of 145 newtons. So the force of tension equals 145 newtons. Both wires have radius of 0.45 meters. So I'm gonna write the radius R, copper, and radius of the steel are equal to each other, and they are 0.45 millimeter. So let's pay attention that this is millimeter. We might need to have to convert it to meters. And mass densities are 7.86 times 10 to the 3 kilogram per cubic meter for steel. So that is the mass density, rho of steel equals 7.86 times 10 to the 3 kilograms per cubic meter, and 8.92 times 10 to the 3 kilogram per cubic meter for copper. So rho copper equals 8.92 times 10 to the 3 kilograms per cubic meter. How long does it take the wave to travel from one end to another end of combined wire? So we need the wave to be traveling through the total length. So on how long does it take? Time is a constant, is a question mark. Well, to find the time that travels through this combined wire, first the wave will go through the steel in a different time, and the wave will go through the copper in a different time. So I can say the total time would equal the time for the wave travels in a copper plus the time in the time in which the wave travels in the steel. Okay, so this is L, steel. Okay, now how do we find the time? So we can find the time equals the length of the length of the copper. So we never wrote what is this 25 meters. So I'm going to call it length of the steel, and then this one 50 meters is the length of the copper. So for the copper will be length of the copper divided by the speed of the wave in a copper, plus for the steel we will have length of steel wire divided the velocity or the speed in the steel. Okay, now the next thing we need to find what is the speed in a copper of the wave and a wave speed in the steel. So to find that, V of the copper would be the force of tension divided by the mu of the copper. Similarly, the speed in steel should be the force of tension divided by linear mass density of the steel. Now the question is, how do we get the linear mass density mu since we have the rho? Okay, so the mass density in general, volume mass density. Let's recall what is the density of the definition of the density. We know density, volume density is a mass per volume. So, and then the volume of the of the wire would be the length of the wire times the cross-sectional area. And as you can see, mass per length here is our mu. So I can substitute this to be a mu by definition, and divided by area. And because it's a copper that has, it's a cable and the cross-sectional area is circle, so the area would be as a pi r squared. Okay, so if I want to find out what is the mu for the copper, that would be rho of the copper times pi r copper squared. Mu for the steel will be rho steel times pi r steel squared. Now we can plug this into our expressions. So this will go into here. The mu steel will go into here, and this whole expression will go up here. Okay, so let's rewrite our equation with everything plugged in. So I would have this time equals time of the copper will be L copper divided by V of the copper square root of force of tension divided by rho copper times pi r copper squared. Let's see, the square should be in a different place. Okay, there we go. Plus, same thing for the steel, L steel divided by square root of force of tension divided by rho steel pi r steel squared. Now if we plug in all the numbers and punch it into our calculator, we will get 0.46 seconds. I strongly recommend you to plug in the numbers and check this value. Thank you for watching.